Hi, my name is Vivian, and my group members are Ryan, Javier, Dalton, and Micah, and we're going to be talking about Newton's second and third law. Newton's second law states that a force causes an object to accelerate and that the acceleration is directly proportional to the force and inversely proportional to the mass. And Newton's third law states that when two bodies interact, they apply forces to one another that are equal in magnitude and opposite in direction. In other words, every action has an equal and opposite reaction. And next up is Javier.
For this experiment, we decided to focus on the concept of momentum conservation by applying it to a common subject most people would be familiar with, that being billiards. The way we integrated Newton's second and third law was by observing how momentum is conserved through the initial force from a cue onto a white ball that then collides with another cue ball. For the equipment and material that we will be integrating into our experiment, we included 2 cue balls, 1 cue, a recording device such as a phone camera, a pool table, and a graphing program such as Vernier video analysis. Before we can commence our trials, there are certain information that we first must know. That includes the mass of a cue ball and a pool ball, as well as the formulas for Newton's second and third law. Then we will be able to continue onto our trials.
For this trial, we can interpret the velocity versus time graph for when the cue ball hit the wall, and we can calculate this with a 3-point shown that it caused the ball to move with an acceleration of 32 meters per second squared. With this knowledge of the acceleration, and since we already know the weight of the cue ball to be 0.17 kilograms, we can use this to calculate the force of when the ball hit the wall, that of being 5.44 newtons, and we can find this by multiplying the weight and the weight of the cue ball and the acceleration. Now for trial 2.
For trial 2, we used the law of momentum, or Newton's third law, to find the momentum of the cue ball hitting the pool ball and then the pool ball hitting the wall. So for the momentum of the cue ball, the final mass and the final velocity was 0.156 kilograms and 1.32 meters per second minus 0, because there was no master velocity at the initial position, and it created 0.21 kg times meters per second. And then for the momentum of the pool ball, we did 0.17 for the mass times 0.25 meters per second for the final velocity minus 0.17 kilograms for initial mass, and then 1.98 meters per second for initial velocity, which gave us 0.29 kg times meters per second.
So in conclusion, this experiment had a small sample size, but it demonstrates Newton's second and third laws very well. So trial 1 found the acceleration as the cue ball hit the wall, using those 3 points of when the ball was actually in contact and then leaving the wall, which allowed us to calculate the force of the cue ball on the wall. And trial 2 found the momentum of each ball and had a reasonable percent error for momentum conservation at around 27% loss, which is most likely due to the initial shot not being completely in line with the second pool ball. So in conclusion, these experiments showed the second and third law very well, and thank you very much for watching.